We'll just start recording this just in case anyone is interested in looking at it on YouTube. So the sphere, old school Jack, how's it going? Project some stuff using the ray node and morph it back to the sphere. Didn't get the notification. I did just start. Sometimes Discord, if you're looking for the Discord notification, so I think the bot takes a few minutes to spit it out. So it might be coming in a second. You like the sweater? Olaf, not much? Thank you. Yeah, it's a nice, to get the full color palette there. Yeah, it's a little colder. It's like in the 60s or something here. I don't know what's going on. We're getting weather. I guess it's like the fall weather is finally coming in. Oh, okay, there's the notification. Surface tension today? We're doing a little bit of it, yeah. So I'm gonna talk a little bit about the sphere, UV spaces and stuff like that. But yeah, I wrote out, I did a surface cache with some tricks and stuff like that. Of what we had been working on. So we'll look at some renders, shaders, and the settings for surfacing this. And I did do some improvements just to the actual simulation itself. So I'll go into some things that I had figured out with that in a little bit. Funky fluid stream. Some funky strings, kinda. Meshing, yeah, the meshing is not. It's a very tedious part, for sure. So if you do a polygon, like all of the sphere kind of mesh, either polygon or polygon mesh, depending on the topology you want. If you press the 5 button, you see that this puts your viewport in the UV space, or to view the UV coordinates. It doesn't exist. So this is, CG Rockstar was asking about blending between UV and world space, or object space, I guess. So you could do UV project. This is an easy way to just assign coordinates. By default, it does this orthographic projection from like one axis. If you just do polar, you could get a standard sphere unwrap. You just press 1 to go back to world space or perspective view. Yeah, polygon mesh. I'm just saying, like, constructed of polygons as opposed to NURBS, Bezier, or primitive, or other things like that. So by default, this will put the vertex attribute on the UVs, the UVs on the vertex instead of points. So that's one kind of gotcha with Houdini, is that vertices and points are actually different. So you could see the difference here is that there's like 4 vertices that make up this corner, or this where the edges meet. And if I go to points, it's just 1 point. So that's the first difference, is that those are treated as different data types. Most other softwares don't make that differentiation. So if you do vertex split, this is how you can move the UV attribute to a point attribute. And the reason to do this instead of just the typical attribute promote is that this will generate a seam, like it will actually split the points where it needs to. So if I look at wherever the UV seam is, I think it might be somewhere around here. These points become doubled up, or they become separated. So if I just do a promote with moving the UV from vertice to point, I guess it would be easier to see it this way, I think. Let's see, could probably find the seam. Okay. So the seam gets all messed up if you just do it with an attribute promote. If you do it this way, it will preserve, basically separate these two points to preserve the seam. This way, these points are still, the edges are still joined, so that's why I use a vertex split instead of attribute promote. Yeah, I don't know if it's necessarily a trick. It's kind of just the hidden proper way to do, I guess, is just, I don't know how confusing it is to work with vertices in Houdini sometimes. So then if you want to, you could just do an attribute swap, because these P and UV are now both on points for where they're stored. So if I do one that's just swapping P with UV, then you'll get the flattened out UV space. And then if you want to blend between them, just the easiest way is the sequence blend. This is the same node that they use inside of the time shift that typically gets used to blend between the previous and the next frame, but you could use it here to do an interpolation between the two of these. So if you wanted to animate morphing between the two spaces, you can do that kind of thing. And then if you were like doing the ray, I saw earlier you were mentioning about rain geometry and stuff like that. So let's say you have maybe an L system. I don't know if there's a good one that's something kind of UV, two-dimensional, project attribute swap sphere. Yeah, so there's a bunch of different ways to do this. You guys are enjoying this sweater quite a bit. So I'm just gonna do a match size with this L system. I think if I plug in this attribute swap with this, then it just fits it or moves it to kind of UV space. You could do scale to fit if you want it to perfectly match everything. Could do maybe more generations. And then there's a few different options you have. You could do the ray sup. If we do this ray over here, then import attributes from hits. Because you've swapped UV with P, if you import, by default, this asterisk will mean everything. So this has P and UV. If you just do another swap again, you'll get everything coming back. There's some problems at the top there, it looks like, with some stretching. I don't know if it's maybe because of this. This stuff is not handling it 100% properly. It looks like there's some stretching where it's just grabbing the top of the sphere where it should be getting the bottom or something like that. Another thing that you could do is just an attribute transfer. There's an advantage to this. Let me take a look and just make sure I haven't messed something up. Yeah, so if you do this, you could get the UV attribute. One advantage to this is that you can do more than one sample. So this takes the average of like 10 nearby points or something like that. And then if I look at this attribute swap, you can see this fixed the top area. So as I do more or less samples, this would average things out more and more. This might also be, sometimes just having more divisions will help have things kind of have accuracy. So the attribute transfer is constrained to only the point, the value of the point attribute. I think one thing you can do with the ray, instead of import attributes from hits, if you do like hit prim UV, then you could do the attribute interpolate. You could get the source prim. So this is going to find the prim, the nearest prim, and then the UV, or just the 0 to 1 position on that primitive or on that face. We got some primes, some views. D-peak skyline. What's going on here? All right. Taking out the trash. So this attribute interpolate, it does a little bit better job than the attribute transfer because it will interpolate basically the point or coordinate values at the corners according to the UV values. So we could do attribute interpolate, but instead of source prim, by default this is storing these coordinates in hit prim UV. So instead of source, if you just do hit and hit, this should be getting it. I think maybe I just have to do my swapping again. I don't know, it should be working. Maybe I shouldn't be doing project rays. I think I should be doing minimum distance. That was the issue that I was having. So even this issue, if I wasn't doing this coordinate, if I just did import attributes from hits, that was the reason why I was getting the seams on the top. So there's, I guess, 3 different options, or a few different options you have here. There's this thing you could do to blend between the spaces. And then if you were, I think, to even pull it in like that, this blending would still, I think I might not have wired that up properly. But yeah, you could do it, figure this out, do a ton of interesting stuff. Let's do maybe 3, 6. Might take some time. This is like a fractal, so it's gets slower and slower with each recursion. Yeah, so it's just a ton of geometry. So I guess 5 is a little bit safer. So that's one way to do it. Let me make another copy over here. And this way. So it looks like these results are pretty close. But then with this one, because this is just kind of snapping it to the nearest grid point or actual point, you'll kind of get some snapping or issues or stuff like that. The video is blurry. Oh no. Is it a bitrate issue or anything? Let me know if other people are having video quality issues. Because I switched to doing Streamlabs and everything. Yeah, people should be getting variable options or whatever for the bit rate, data rate, and everything. Like number of pixels, 1080, 180p, 280p, 380p, 480p. So this is The 7th. So I'm just calling this like UV to object space P or whatever. So you should, oh no. My thing broke. I don't know why it would have broken. Let me see. We should be good. I have the script that I had finished recently that allows me to share everything. I don't know if I was cleaning up the code and I broke something. So I'm just gonna pop it open real quick. Let's see, there's like some passwords and stuff like that that are in the script. So I just have to turn the screen off for a second. All right. The sweater is popping, HD. And a macro shot of it. The threading and stuff on it is actually a good reference for if you're doing weaving and stuff like that. So could try it again. None type. Yeah, I don't I don't know exactly what would have might be. I'll just try it one more time. Uh-oh. I think I did it wrong. All right, I'm just gonna give up. I'll put this on the shared folder. I think. All right. So I'll try one more thing with it to see if it will send. Otherwise, I'll give up for right now. I'm just talking about the Google Drive, the shared directory that I usually post on the Discord. The link share or whatever, if you go to the stream archive channel of the Discord. RH2, how's it going? Yeah, it's just the stream archive. So underneath each stream, usually within a few days or whenever I'll get around to it, I try to do the scene files. So it would be there for today if I'll just try this one more time. Ah, okay, I did fix the codes. Yeah, I don't know. I was trying to close the socket and FTP connection or something. It looked like that caused issues. But if you click that link, you should be able to get it now. So it's even more immediate. Then we can keep it going even for this anti-gravity scene. All right. We're repaired. Back in action. So let me just go through. Before I get started, I'll do a share for this one. Looks like my shelf is missing. So if you want to get the latest working file for this effect, that's where you could find it. Unfortunately, you wouldn't get the cache. The particle cache, it's a little bit too big of data. It's like 10 gigabytes or whatever, so it's too big to be hosting and distributing that stuff. But just to see the settings of the nodes and everything like that, it should at least be a little helpful. So one thing I did find was like, which would you prefer, ad industry or feature film? I mean, it depends a lot. It's fun to switch between the two of them. Some of it's a little bit of a calculation of like where you are in your career and stuff like that. So me personally, like the ad industry is more interesting because you get to switch between different types of effects and projects and stuff. It's more of like a monthly cycle for how long you would be working on a commercial or an effect or an ad or something. The feature film, like you could be doing one film, one task for a year or 2 years even, especially places like DreamWorks or Disney or Pixar where they do their own films. They have it in production for a long time because they're like their own client. The links are not working. It looks like it should work. So one thing you can do with that, I mean, yeah, they should work. It might be an issue on your end. Oh, I posted too much of the message. Get the emojis out of there. Let me just copy it again. Yeah, it should be working. So with the feature film, like you could get stuck doing the same thing for a longer period of time. So that's kind of the up and down side with that aspect of it. With building your own portfolio or your own reel, doing ads or commercial work, you can build a big breadth of effects and styles or just a big library of build your resume out pretty quickly. And then if you do feature film, you might be working on the same project for 2 years. So you would only get like 10 shots, but it would all be from like Iron Man 3 or something like that over a 2-year period. So that's why I was saying like it depends a little bit on where you are in your career. The advantage of feature film is that there's a lot more money being spent on it, usually a lot more artists working on it. So like the polish, like the amount of refinement and stuff that goes into the work that you produce it's just a higher tier. So it's a bit of like quality or quantity situation in that regard. And then just in terms of a career, the feature film work is usually a little bit more stable. Usually it's like a longer term contract or a staff position, where advertising industry could be a 2-week contract or a 2-week project. 1 or 2 months I find for Houdini is usually the norm. So it's like, that's kind of the breakdown there. Hopefully that helps. So one thing I did do on the DOP network here, I did increase the min and max substeps. I don't remember who, it might have been player 2. Someone last time was saying that they were noticing like some zigzags, some jagged edges in the fluid mesh. Let me see if I have some flip books that show it. This one might have a little bit of it. So some of this business, I think I narrowed it down that the default is 1 substep minimum and 2 substeps maximum. So I think the issue with that is if you don't have enough substeps, the surface tension doesn't necessarily stabilize. So it's always in this imbalance of kind of overcorrecting. So like once I adjusted and jacked up the min and max substeps, I was trying different numbers, and I eventually ended up here to fully like resolve that issue. I figured that was the best way, or I don't know, the most stable way to kind of solve that issue. So that was one thing that I thought was pretty interesting or important or whatever to figure out. So even here you can see it again, is that moving to a higher resolution, it kind of looks even worse because it's like very unnatural to see that kind of features or whatever at this scale. And then this is the same scale or the same settings, but moving to higher min and max substeps to get rid of the, I don't know what you want to call it. It's like you cut something with the scissors, with the jagged edge scissors or something like that. A sawtooth, I don't know. Yeah, you could use the sawtooth one you're talking about in a horror movie or alien movie. I mean, it's pretty easy to introduce kind of unnatural instabilities or stuff like that. Like if you just add some noise with a really low pulse length, or like every frame it's a different kind of direction or something, or you just add like a really high frequency sine wave to the amplitude of a noise, like you can kind of force those errors. But it's just good to know like what causes them and how to clean them up or get rid of them or whatever. So yeah, then today why are you losing so much volume? So by turning off reseeding, you lose a little bit of volume. The surface tension, you can lose some volume as well, because stuff will cling together. So if you have too much surface tension, stuff will compact itself kind of. I think I ended up adjusting settings and stuff enough that issue went away, or got a little bit better. But yeah, it just depends how high you want your particle separation to be. If you add more iterations, you might be able to preserve volume a little bit better. Oh, you got an update on the Lambo. Ah, very nice. You're doing the Vellum sim? Oh, you were sculpting the cloth? It seems like usually with cloth sims, you typically will end up with having to composite a few different simulations. Like sometimes people will have the same topology but run a few different simulations with different settings, and then mix and match the features that they like based off of like painting weights or stuff like that. Yeah, if it stretches too much or things like that. But yeah, if it's just a still you're after, you could get away with kind of sculpting and even just adding like procedural noises and stuff. You can get some good results that way as well. But yeah, like the lighting environment, this floor is looking pretty nice. The sides are low res, and then the top is the higher. That makes sense, yeah. It's like this stuff here looks too funky with the low res. The way that it would stretch and lay on how tight like it would grip the corners and everything. But yeah, this is really cool. So you're going to do it in motion, the reveal. Yeah, that should be pretty cool. So yeah, with the volume gain or loss, like this reseeding is intended to kind of avoid that or balance that. So if that's a big issue, you turn that on. The drawback to reseeding is that it changes particles, like so you could sometimes gain volume over time if your values aren't too correct or dialed in the right way. And then it will also change the point count. So you need to make sure you're storing the particle under behavior. You add the ID attribute if you want to do like time blending or just have a consistent ID per particle. So I usually turn it off. If you're really concerned about preserving volume, there are some other things you can do. Like sometimes you just animate a slow shift of things moving up, and then you keep like a solid amount of particles below it or stuff like that. The other stream, where you guys, which stream are you guys hanging out in? So that's the main things that I was changing. Also was adding a bit of drag or the air resistance. That's another thing that I found that kind of can stabilize some of that like zigzaggies, or basically helps with small scale fluids where you want like smooth, stretchy kind of surfaces and stuff like that. Adding a bit of drag or air resistance can be cool. CG Rockstar is putting in the power hours today. Does not matter which render engine or software. Yeah, I think everything these days is so good you can produce amazing results with any tool. All right. So those are the main changes in the simulation. And then going over here. So this cache I was showing earlier was around 10 gigabytes. And even that was with reducing the amount of attributes. Like the flip simulation itself will come with, once it starts simulating, like if I advance one frame, might take a second to cook, but the solver adds a good amount of attributes for the particles, like previous position, all the force, acceleration, and all that stuff. So I think it's just taking another second. 970. Yeah, I think even just a single 1080 is starting to be a little. For me right now, I'm using the one card when I'm usually rendering on stream. It should be close to like 2080 or a little bit faster, but even that, because I have the 8000 or whatever, but even that seems a little slow. All right. So you see it has air resist, force, p-scale, target v, lx, ly, lz. There's just a lot of extra attributes you don't necessarily need. So it's already like 500 megabytes just for these particles. And then getting rid of those extra attributes brings it down to 100. So it's like 1/5 of the size. So if I didn't do those steps to strip the extra attributes, I might have ended up with like 50 gigabytes for the cache. And then not only is that to save hard drive space for the cache, but also if I just play this, you can see it's not exactly real time, but it's playing back at like maybe 4 or 5 frames a second. If I had all those extra attributes and if it was like trying to load a 500 megabyte file, it would probably be like 5 times as slow as opposed to 100 megabyte files every frame. So even performance of like reading and writing, it will just be more optimized to strip out those attributes. And then one thing I usually do with Flip is just promote the p-scale from a point to detail attribute. So if we look at these, just go back to the first frame. So if we look at these spreadsheets here, for a detail attribute, the p-scale just gets stored. It's like a uniform value all across the entire geometry. It just gets stored once at the detail level, which is like all encompassing. So it's points, vertices, primitives, and then detail is like metadata that's global across all the points share the same information or the same value. So that because p-scale isn't changing per point, just for caching, there's no need or no reason to be storing it a bunch of times or whatever. Removing redundant attributes, etc. My sim suddenly cut in half. Yeah, it's kind of tedious to manage this stuff, but like it definitely makes sense in the long run, especially if you're iterating and doing multiple versions and stuff like that. Yeah, the one thing you do have to remember is like after you read the sim back to disk, usually you have to promote the detail back to point attribute. These VDB from particle nodes, if you're going to be using it, like they're using it as an additional multiplier to this point radius scale. So if you forget to do it, it can mess up your values and stuff like that. Vegan Nuts, how's it going? Yeah, so it's like I was saying, it's a bit tedious. Like it takes a minute or two to set up, but it's definitely worth it. As you guys are finding out, like can save you. Some time could get cut in half. I haven't typically experienced that level of gains, but it's definitely enough to make a difference. So there's one thing I was seeing really pushing it was Igor Zanich. So he's talking about, as a freelance artist, doing a lot of heavy flip simulations, working with like huge caches. And then his play blast times were taking a long time. He was looking into some PDG network and doing like play blasts, like distributed play blasts or stuff like that. I haven't pushed it that far, but as you are working with more and more data, just more complexity, you definitely need to start like really worrying about or finding interesting ways and stuff like that to optimize your caching or your data or stuff like that. Is the release of Houdini 18.5 on the 15th, or is it just a live stream? I'm not sure. I don't know if anybody knows. Yeah, I think we were looking at the teaser, the original video they released earlier, and it just says like more info on the 15th. So it's a bit of they're pulling a bit of a Houdini on us there. It's a bit of a mystery. Happy birthday, Vegan Nuts. I didn't know it was your birthday. So that's the idea with this p-scale, is just at the time of cache, you can move it to the detail level. It's a bit of an optimization. Yeah, and then I'm just using this VDB from particles to surface things. So they have the particle fluid surface node that is like a kind of just more simplified workflow of all this stuff. It has similar settings on it. And if you look inside of it, you'll see that they're just doing things with similar things with VDB operations. There are extra ways you could like kind of do the same thing where this is dilating, expanding the surface, then you can blur it, smooth it, and erode it again, add additional smoothing. I usually prefer not to use this and just work this way, and then I can visually see, kind of just toggle things on and off if I need them, or if I want to do like 2 different smoothing operations, it just is a lot more flexible. So it's the same idea as the particle fluid surface node that it creates by default with the shelf, but this way is just a bit more control over things. So dilate just expands the surface by 1 voxel, so everything gets kind of peaked or inflated. Then just smoothing, doing this mean curvature flow. So the whole idea with this stuff is that you're trying to make your water fluid appear flat and smooth as possible in most areas. So if we just look at this line, just make it go horizontal. This might be a flip simulation, like flip particles. So if I do add, delete geometry, but keep the particles, this is like a particle separation of, I don't exactly know, it might be like, let me take a look here. You just go from 0 to 0.05. So it's roughly a particle separation of like 0.05 units. But it's trying to basically describe a fluid that's like perfectly flat. So if we look at VDB from particles with this, we're saying our particle separation is 0.05. You end up with this blobby result because you would need like an infinite amount of particles to do that. If you really wanted to push this, like if your particle separation is really small, you can fill in the gaps that way. But usually with flip simulations, you don't have the possibility or the capability to. I'm already pushing things here with almost 9 million particles. You're always going to run into this problem, especially if the camera is getting closer to things. Further away, it's less of an issue, but it will always be a problem. So to fix this issue, the typical trick is to do this. You could just simply do VDB smooth SDF. That's like a blur, and that solves the issue somewhat. But you can still see there's a bit of some rippling or stuff like that, especially when you're rendering this. If I do convert VDB to polygon soup, certain angles and stuff like that, or a refractive surface will give you really unnatural distortions. So that's why you want to spend a lot of time making this surface appear more flat or generally smooth. So the next step up is to do this reshape SDF. It expands it by 1 voxel radius, and then doing a smooth in this expanded space, and then doing another reshape, but this time instead of expanding again, going back the other way to erode. So it's a little bit subtle, but you can see it's a little bit more preserving of like a flat surface. And then as you push like resolution, or you push these values around, we just try going to a voxel radius of 2 units for the blur. This is more easily preserving the surface. And then it's usually a good idea to like check your input and check the output and make sure you're not losing too much volume or things aren't too different from where they started from. So if you want to, sometimes doing like initial dilation of 2 units and then just eroding to 1. Because this smooth, you lose some volume. So sometimes to counterbalance that, you need to dilate further, or you could as well just start with a little bit bigger particle scale. So this multiplier will move things that way. So that's the idea behind these filtering operations, is that you're just trying to get to an end result of a surface that appears smoother in the flat areas and still relatively looks at the same space, like occupies the same space. So that's what I'm doing here. We have this is particles to SDF. Then we're doing dilate. Blur, let's say mean curvature flow. There's different operations you can do. Median value, Laplacian, mean curvature tend to preserve high frequency detail pretty well. Gaussian does like a very big, just like averaging or blurring you lose a lot of detail doing some of the too much Gaussian. So that's what we're doing right now to end up with this surface. Again, let me finish naming these a little bit. Road. So we'll do SDF to mesh. So yeah, if we look here, this is the same idea as this surface here would be pretty ugly to render. The refractions as well. If you're looking through a kind of tank of water or just a pool of water, it's just super unnatural to see these little like pockmarks or whatever. So doing these operations gets you a little bit closer to something. You can still see there's some issues, but for the most part, it's a lot better. And then the last things I'm doing over here is like a little bit of an extra trick or something like that. So with this analysis, you can find the curvature of the mesh. Let me just go to a different frame. It's not just a box. This one should be pretty good. All right, so everything is still pretty smooth. There's still a little bit of like lumpiness that might be unnatural. So with this curvature, it's terrific. Thank you for the 3 months, tier 2. Let's go. So with this VDB smooth and analysis, curvature is just finding where the flat areas are and where the kind of like curved areas are also like detailed areas, or areas where the direction of the mesh is changing very quickly. So you can do this, and then attribute from volume is taking the volume value at the current mesh position and retrieving it, converting it to an attribute. So the volume value is getting passed to the mesh as an attribute. In this case, it's just color, because it's the default setting for attribute from volume, and it's simple to visualize. And then with this color, if you want to remap things, you can kind of adjust the range. So the VDB analysis, it will have negative values. If you want to find different curvature, you can kind of get something like occlusion. Sometimes if you turn off the lighting, when you dial in the values, that can be a useful way to make sure you're looking at the specific area of the mesh that you want to. you would see that the specular highlights or whatever sometimes interfere with your interpretation of the values. My intention with this is that you find the flat areas, and then I'm doing like a peak. It's kind of subtle. Could exaggerate it more. To pull in the, let me do this. To pull in the flatter areas to kind of simulate like a bit of surface tension. So fluids on the edges or where they're clinging to things, like on the corners, they usually have a bit of a raised lip or like a bunching up kind of. So kind of faking that idea, like a bit of faked surface tension or whatever. You can see here I'm pushing it too much right now because I'm just showing what's happening, but if you do it too much, you'll get areas that are passing through each other. But I'm just doing the current point position moved the other direction of its surface normal and then multiplied by this color value, but like inverted 1 minus. So if we go back to the colors, the black portions of the mesh will get peaked. So it's the same idea as this peak node. But doing it in a wrangle, you can control things by an attribute or additional values. The peak node itself, you don't have any control over it. It's a uniform value across the mesh. So I'm doing negative, I don't know what it was, 0.01. But only in the flat areas, if that makes sense. And then the other thing I'm doing is making an output of this mask, again, that's flipped around, and then just calling it blur. And then you can use that attribute as a weight. So the reason to do that is color is a vector attribute. I want to just make sure it's a float attribute, and then I also want to do the conversion or inversion or whatever of it. So this way, you can do a blur, just a localized smoothing to the mesh, but only in flat areas or the low detailed areas. So without that weight attribute, you can see I'm like really destroying or thrashing a lot of the thin ribbons or streams or stuff like that. We just add it back in, blur, and we're preserving some of those areas. I might be doing this a little bit too harsh, like maybe expanding the range. It's a little bit better. But that's the idea behind this stuff here. It's just doing remap curvature. We'll just call this transfer curvature to mesh. This is like peak by curvature. And then we're doing a blur by curvature. And then this, just clean the extra business up to keep things looking or lightweight. We just want the point position. We don't want to keep extra attributes around on the mesh. Just do clean extra attributes. And then lastly is this attribute transfer. Just to pull the point velocity. So the actual flip simulation, I didn't save it because I wanted to keep the file cache light. But if your point count isn't changing, or if you have the ID attribute, you can recompute the velocity on the particles. And then for motion blur, or that kind of stuff, you can still do it by the velocity attribute. Because this flip topology will be changing every frame. So you can't use deformation motion blur. You could just blur based off of the attribute. So you'd see my cache, I did it earlier this morning, so it's a little bit different than these results. It's similar settings. So just making sure this area here is smooth, doing those extra steps. This lumpiness and edges getting rounded or cropped like that is usually like a pretty big thing that you want to hide. It depends too on what type of fluid you're doing. If you're doing like a jam or jelly or something, you might see more of these features, but I don't know if it's like milk, or it just depends on the consistency of the fluid and stuff that you're trying to represent or you're trying to simulate. So then this surface cache is pretty much ready to render. You have velocity information, and that's pretty much all that you need. The shelf tool will put this render flag here and just make sure you have it moved over. Off to bed. Take it easy. Hopefully that file made its way to you. The UV space one. Yes, of course. We'll just move this to a higher version. And should be good to go. So the shelf tool will assign this basic liquid material. If you're going to be using Redshift or anything like that, just want to get rid of it. I think I might have already deleted it. You just press Shift W on the network view. You can get this extra kind of scene thing. So even other networks besides the object network, you can see like what nodes exist there. Node genome, of course. Thanks for hanging out, stopping by. Then usually I will just keep my materials in the same network. So if you're reusing a setup, it's just easier to drag everything, Control-C. You do a new Houdini file, you can do Control-V and put it in pretty easily. And just do the Redshift material. For lighting, kind of depends what lighting style and stuff you want to go for. The easiest way is to usually start maybe with a light dome and a texture. Skadooks! How's it going? A long time no see. So usually I'll just start with this kind of studio HDRI. Maybe this. HDRI Studio. Those are a bit warm. Even doing something looks simple with like these bars, it could be worthwhile. Great tips for smoothing out VDBs. Yeah, I think that's one of the most powerful aspects of Houdini. I know the VDB technology or plugin or whatever you want to call it exists in other software packages, but the ability to like composite things, generate masks. I do this with other types of meshes as well. We'll transfer attributes of curvature or things like that, and then even for rendering, you can use this as like an attribute in the shader. For fluid, it's not super useful. I don't know, maybe if this was like lava or something, you wanted like thinner areas to glow more or something, you could do that. But just having access and everything like that to all this low level stuff is pretty cool. super useful. They just name that point velocity. And then on the Redshift object, just make sure you have mesh deformations from velocity attribute. Otherwise, like I was saying, it will try to look at the previous and next frame, and the topologies won't be the same point count. Like it will look for point 19,326 or whatever it is, and then the next frame that point will be somewhere else completely, and it will just be a jumble if you try to motion blur it that way. All right, just gonna go back to this front view, control click to add a camera. Just try to zero out the settings a little bit. All right. So I don't know why this light, maybe I have to go into this view. Kind of see the light on the mesh there. So yeah, if you start out with a fluid, sometimes just having these lines or just lights above and below it is a good starting point. Lighting like a reflective surface is pretty difficult, but if you just start with symmetrical lights, it's a pretty standard way to light like metallic or reflective surfaces. If you look at like wine bottles, a lot of photographers will start with this kind of symmetrical. So none of these are doing, this one's kind of doing it. So they just have two grid lights or area lights on either side of that. These ones, they're doing some different stuff, but as a starting point, just having a light on either side is a simple way to kind of define the edges, get a good shape out of the box or whatever. Then on the shader, just go to water. Does do dispersion by default, like it gives you the closest value it thinks to what's real life, which is nice. All right, let's take a look. So yeah, you can kind of see what I was talking about a little bit with the lights doing a somewhat good job of showing the top and bottom of things. Sometimes if you want to, these HDRIs are a bit limiting, and just going with a grid light, you have a little bit more flexibility. Just do RS light. I think we need to rotate it. Just move it up like 5 units. Looks like it's upside down. Now you can see it. Usually these will get quite big, I think. I don't know what's going on here. Let me just make sure I haven't done something stupid. Yeah, I don't know where that extra stuff would be coming from. Let's take another look. It might have been because I was rendering, like I had this display flag turned on. Sometimes it just needs a reboot, like you're adding new lights and stuff like that. And I think these lights here are a little overexposed. Can be an issue. Like the default setting is 100, and then when you make the size bigger, the intensity becomes kind of bigger as well. Let's go maybe wider. Another thing you can do is just rotate everything like 90 degrees. Like you're just looking through. So the light's invisible, but it would be right behind everything. And then this is another way to get like the edges kind of showing up or whatever. Just to define the silhouette or the shape of things pretty nicely. Might go let's go like 10, 25. So I'm just going to try putting this kind of on either side of everything. I think getting like a bit of an angle is starting to be pretty cool. Photons. Yeah, that's one of the big problems with like reflective, refractive surfaces or whatever is you get some issues with light gaining intensity and stuff like that. One thing sometimes people will do, I think, with Redshift reflections or refractive surfaces, adding like a bit of shadow opacity. Sometimes that can like protect you from getting like these internal surfaces or areas or whatever that get blown out like that. It's a weird thing to think about is like, yeah, you could do volume absorption if you're doing like bubbles or simulating some murkiness inside of stuff. The shadow opacity is kind of like along the line of thinking of caustics. At least that's kind of how I think about it. So like the if you do caustics, you can turn it on. I don't have things to catch it right now, but the way caustics work is that there's a actual shadow that the brightness of the caustic is pulled from the dark area because it's like refocusing the light. So by default, if you have shadow opacity of 0, you'll just purely get like an additive caustic or like additive reflection. Disable cold dim internal reflections. Does that help as well? I didn't know about this one. This is meant to keep the light from gaining intensity inside of it. It's his number 1 tip. Sol is the god. But yeah, I think with Redshift, and I've noticed it with V-Ray as well, is that you'll just get super unrealistic like internal reflections of things where it's like just preserving way too much energy or too intense. But yeah, usually with it's not physically accurate to just reapply the shadow the way that I was doing it, but it's a lot better than just missing that darkness completely. A lot of CG caustics are just purely additive. So if you don't have that dark lobe in some way, it will trace depths. Yeah, that can help as well. But yeah, like this one right here doesn't have any shadowing or any darkening. So that's one like immediate giveaway that it it looks kind of fake. Spooky Mabel, how's it going? So let's add the other light in. Just gonna do somewhat symmetrical kind of thing. Houdini magic. 23, oh my God, Blake Catherine, thank you for the raid. Need to resync my time so I can raid you again. Yeah, we're doing a flip simulation right now. Take a look here. So I was doing this kind of anti-gravity stuff of things dripping from a pool going to like the other surface. Just looking at some rendering lighting stuff with Redshift right now. This is kind of part 2. So yesterday, or not yesterday, but last stream on, I think it was Sunday, we're doing the actual simulation. Now we're doing some surfacing and meshing of everything. But yeah, thank you for the raid, Blake Catherine. I hope you had a good stream. If you're not following her, be sure to. She does fantastic still lifes. So let's move this other light over. Sometimes I'll do it just typing in coordinates. I don't know how well it's gonna work here. Doing like a 180 degree, doing like the rotation in your head or whatever of this stuff is sometimes a bit of a pain. Let's just do it this way.
Welcome to the internet, your gateway to adventure.
All right, so this is my super sloppy lighting setup. Put it in on Twitter. Her TikTok is really cool to watch. TikTok is interesting. It's like almost made for cool like CG loops and stuff because it will just keep automatically playing again and again. Yeah, I don't know. I feel like Instagram for video loops isn't necessarily the best just because it's like inherently a still based format or whatever. It's like just seeing it in the feed, or I don't know, the way people consume it is a little bit jarring, I guess. I don't know. So just going to 1 for the exposure now, keep some of those areas from getting like too blown out. Then of course the bits of tone mapping and stuff you can do with the Redshift is super useful. Keep stuff from blowing out and all that business. So yeah, with this water shader, going lower with the dispersion will give you more rainbowing or whatever. It seems like people are usually over exaggerating that and getting some interesting results. And then another thing is like right now everything looks super sharp, so we could go to the Redshift ROP and just activating motion blur. So instead of making the specular component more rough, like blurry, if you do motion blur, it will kind of have the same effect. So I think by default, I can just do it this way. Just using the dispersion's fun to exaggerate. Maybe I need to turn on the mesh. Yeah, you can get some really nice, like, there it is. Really nice prism kind of interesting, super interesting color gradients and stuff with it. But yeah, this can be helpful. Sometimes I'll go a little bit more sharp or whatever with the shutter. So like right now from 0.25 to 0.75 is like an 180 degree shutter, or like half the frame the shutter's open. If you go from like 0.4 to 0.6, just do a still, probably just do a bucket render. This will still preserve the motion blur, but it's just not as exaggerated. So again, it depends on like the camera you're trying to replicate, or just usually I'll go a little bit sharper with it because I think it preserves some of the detail and it will look a little bit less, I don't know, it's just a little subtle. Let's go back to the IPR. And go back into the water. See how much we can push this dispersion. Seems like when you get below 1 and 2 or whatever, will get really funky. This is a really cool look, but I do notice like if you go really far with it, eventually you'll kind of get this noise, or like it will take a long time for the renderer to like cleanly resolve some of it. Whoops, maybe just like 4. Like super psychedelic. All right. So this will just be our default water. You're enjoying this? Super cool. Maybe this will be like tint. So if maybe this is a wine or something like that, just assign it. So usually for a colored fluid or something like that, even honey, starting with tinted glass is a good place to go. And then choosing your color or whatever this way. It's like oil, filling up your the oil of the dipstick or whatever. Maybe this is a little bit more honey, appetizing. I don't know if honey technically has it, but it seems like usually adding a bit of roughness in with the viscous fluids or stuff can be, I don't know, make it look more appetizing or whatever. I'm just gonna go back to HDRI light. I feel like the area lights you can dial in some really good looks, but it does take usually more time to like balance your levels and stuff right. It's super easy to get things that are like really overexposed or unbalanced, because like distance, size, and all that stuff plays into the equation with when you're like manually lighting things. Let me see what else. Then just usually rotating these studio lights like in increments of 90 degrees is just like looking down a different axis of them or flipping it. So I might try one more with some subsurface. I don't know if it's working. The drag and drop is a little slow today. All right, I think it's working. Let's just double check on the, I think it got it. This will be subsurface scattering fluid. Big booty. Did John Travolta have a... He's still alive, right? Absolute dump truck. Travolta. So I'm just gonna try Milky Coffee. Start the renderer again. So I don't know about specular, but this does a good job of like the volumetric scattering. I think because by default it moves the IOR to this, which is the equivalent of like 1, or essentially saying it's purely the only appropriate use of the term huge. So go to just IOR, maybe not advanced, regular. So if you want to get some specular back in, you can do it that way. And now we're back. This is Shrek's swamp. Do you ever look at the fluid from the start of that movie? They do the credits or whatever with it. The opening credits. He's like grabbing snails and whipping them around. This is like, DreamWorks made this before the fluid solvers were really advanced. So all of this things there, I think they were just doing it with like metaballs, with like regular particle sims without any fluid business going on, but it's still got some interesting results and looks and stuff like that. Yeah, it seems like all the, I think just because there's like people with super good eyes, like creative eyes, or I don't know what you want to call it, artistic, like even if you give them really shitty tools, they can still produce results that look good. Of course, every swamp, every DreamWorks movie has fart jokes. It's like you see the little gas coming. So that was the way that they were like, we're not Pixar. We have fart jokes in our movies. We're edgy. So yeah, we're just adding adding some specular in. I might be a little too over the top with that roughness of it. Maybe to see if we can get something, some body. That is the one song. There's certain songs where you just hear the first lyric of it, and you can instantly identify what song it is. Somebody. So I'm going to try to get a little closer to maybe an orange juice and see what happens. So I think this hue is going to like the opposite side of the color circle. Some of it is like, this is the light that's being absorbed, and then the opposite side of the color spectrum is what's attenuated or like passed through. I think it just depends on your mode. If you're in extinction mode, then it will be this way, where it's like, this is the light, or this is the color that you're removing from from the refractions. Then the saturation that I was moving around there, that just seems to, it's like overall, how much do you expect of the effect to be happening? Could you please abuse some of the sim particles to put air bubbles? Yeah, we can do that. Revisit the Sandman, make clumps of grain turn water after a few minutes. Oof, this is the alien goo. All right, this is a little, this might be, I don't know, it's a little fake for orange juice. Maybe my scale. The scatter scale, it's like, it's kind of like with Redshift volumes or whatever. It's a weird balance that they have going on in terms of the kind of like internal shadowing. Yeah, it was looking more drinkable. Not anymore, but I think it was looking pretty good. Yeah, I guess, I don't know, orange juice is pretty vibrant. It's a balance between juice and radiator fluid. It's also like, if you make screwdrivers or mimosas or whatever, that's how you can always tell how much of it is like alcohol. How easily you could see through the glass or whatever. Seems like pure orange juice, it's like fully opaque, or it's very difficult to see through it. But then the more champagne or prosecco or vodka, whatever you're adding to it, whatever mood you're in, the more transparent it gets. I'm just gonna try to get a little bit closer to the orange. I feel like the yellow is definitely adding more motor oil kind of vibe to things. What mood? Shuffling through your liquor cabinet? What mood are we in today? Yeah, I don't know, maybe my scatter coefficient, just leave it pretty desaturated, it seems like. 2 proof. Yeah. All right. This is pretty good. Somehow I got my saturation boosted. Okay. That's starting to look pretty drinkable. So someone suggests a way to transfer transformation. You're going to transfer transformation? You're breaking some brains with that one. From ABC to another geometry. Sim bubbles in the glass at the origin and need them to follow the glass. It's very difficult to know just without seeing like your file or seeing more of your circumstances. Sometimes depending on how you are importing Alembic scenes, like if you do an object level thing, you do Alembic archive. I don't know if I have ones super easy to access on the disk. I might have some stashed away somewhere. But building an Alembic archive at the object level, you can get transformations and parent stuff that way. Let me take a look here. So this will build transforms and stuff like that in kind of like a rig or a parent situation. Might not have worked. I don't know if pulling in the address that way worked or not. I don't know if I have ones that are easily accessible on disk. So you can see some of these have different, like, just hierarchy or structures. So like if people animated in Maya or whatever, like parenting things to nulls, sometimes you can retrieve or fetch the transform this way. It doesn't look like that's necessarily the case with this one. But it's pretty cool. So if you did have those transforms, you could do like, you could fetch that transform and use it. If you do geometry, I think it's like, this extract transform is a newer thing. Extract object transforms. There's ways to do things. I don't know. It depends a lot on what information you have available to you. You like the scene? That was from this Sun Ladies VR thing that I worked on a while ago. It was like these women were telling stories, like battle stories or whatever, so they just animated their kind of like a dream sequence or whatever like that. It was like the narration of their that stuff. I think you'd still find this experience on the Oculus store. I think it's still available there. It's pretty cool. Like you're able to move through that space and interactively, like there's like parallax and stuff like that as the bullets are moving around. I don't know if they put any of those scenes in the teaser. But yeah, it's pretty cool. All right. So no genome, if you can post files on the Discord or somewhere like that, you just at me. I could take a look there. But there's a ton of different ways to kind of reparent things if that's what you're after. But it just depends on kind of what information you have available to you. Calculate the rotation. Yeah, it can be easy to get lost in like matrices or weird parenting schemes or stuff like that. Sometimes if we just do like a tube, that extract transform thing that I was doing, that was a newer way. What the hell is going on? All right. So that extract transform thing can actually work sometimes. Maybe if we just do polygon, this is like our weird little thimble, shot glass or something. We could make it somewhat into a, just keep the back, reverse everything. It's a little bit weird, but whatever, you get the idea. So if you're scattering, save that group, the back just so I could scatter on the outside faces. And then let's say you have some animation. I'm just going to do this like inside the object. And maybe this is flying around like this. So these points aren't going with it. If you do this extract transformation, this will look at just the difference between things. And if the topology isn't changing, like the point count is the same, it will give you this single point that records the translation and rotation of everything. If you look at it, it's basically the offset, pivot, and orient of things. Orient is a quaternion attribute. It's a bit intense or difficult to work with those, but if you do transform pieces, this node is automatically set up to look for those attributes and apply that transform to things. So if I just take my point cloud and the point that I want to apply, might need to turn this off. This should work by default. Maybe I need a name. So as this moves around, these attributes should update. Let me just assign a default name. Just assign it to both of these. This is kind of what it's trying to use to match stuff. All right. So I didn't describe it perfectly well, but you can see it's working. It's working now. So there were a few things I had to change. It was just looking for this name attribute. If you just wanted to use piece 0, it will work. And then to assign this name at the primitive level, I needed to add the points to a particle system. That will just have a primitive that they belong to, so that you could assign attributes to it or whatever. But this is one way to basically reparent things to animated meshes, as long as your topology isn't changing. If you're doing like a fluid simulation and you want the bubbles to match, then you might just have to like re-advect them or do something like that, because you wouldn't have a fixed topology to match to. But if you take a look at this scene, I'll just do another share of it. Whoops. You could look at that group of nodes and take a look at it. Maybe it will help. All right. So we're gonna add bubbles to the orange juice. Because we kept the flip simulation stuff, can do the trick of just orangina. that has carbonation to it. Orangina. So if we look at these points that we kept, the point count isn't changing. So if you want to, you could just do like a blast. Do something like 0 to 50. So it should keep 51 points. It's like 0 to 50. Delete non-selected. Then we have 51. Anti-orange. And then these, the point order or whatever is a little weird. You could just randomize it. Did it work? I think it's taking a minute to think about everything. All right. This might be a little too slow to randomize. Anti-gravity orange juice. Is it the, what was it the astronauts were drinking? Was the, you remember there was a period when Tang like teamed up with NASA or something? They said this was the beverage of the astronauts. This is basically like make your own lemonade or whatever. This kind of looks a little bit like Tang. They invented it. Whatever thing NASA was on in that era was, they were making some weird stuff. But yeah, this is super vibrant. Are the Wu-Tang in space? The freeze-dried ice cream, yeah, everything they were making was super sugary. So I'm gonna try randomizing before the trail. Because it's randomizing like 8 million points every frame, it's a little slow. I'm just gonna do my deletion a different way. So if I just do if a random number based off of the point number is less than 0.95, delete the point. So this is basically how many, the percentage of your total points to delete. If you want to, you could do a channel reference. Just do PCT, like percentage. Click the, where did it go? There it is. So the reason I wanted to do it the other way was because you could explicitly tell it how many points you wanted to keep. We'll just go this way. Just get really close to 1. We have 75 points. And if you want to add a different number to the before you generate your random, then you can do like a seed, a different outcome. So this will just re-randomize everything. Bone loss from the lack of gravity? I think it was just the time period of everyone wanted really bright beverages and like really sugary, absurd foods. It's like the like sticks of chalk you would dip in the powdered sugar and just eat it. The crackling, the candy that you would put in your mouth and it would like crackle or whatever. Like, you know, this is all super weird ideas. No one would invent that these days, right? So just do call percentage of points. So the idea with these is that you leave behind a subset of your total points. So from the 8 million points of the flip simulation, we're keeping 75, and then copying spheres to these that will get treated as internal bubbles to the orange juice. There's more advanced, this is what Age of Enlightenment, a snack food renaissance. So if you want to, there's more advanced ways you could do things. We're calculating velocity here. One thing you could do instead of like hand selected percentage, you could use that velocity as an attribute as your threshold and do like the high velocity areas are more likely to produce bubbles. So there's a lot of other ways to customize it. But by default, this will just be a fixed constant set of points that will get turned into bubbles. Usually I just switch them to polygons. Redshift won't understand the primitive Houdini data type. So you just need to convert it so that they're actually like faces or triangles or whatever. Then just do reverse, just flip them around so that they get treated like internal pockets of air by the renderer. So when you merge these with the final surface, there's some that are sticking out a little bit, but as the ray goes through and traces through the surface, you want these bubbles to be flipped around so it thinks that it's going from inside, hits a reverse or a back-facing face, and then it thinks that this little pocket is air. If you don't have them reversed, then the renderer gets confused and it thinks it's going like back into another fluid or something like that. All right. Let's just go to another frame. See what we get. Stuffy, thank you for the Twitch Prime. I appreciate it. How have your streams been going? So I think I haven't kept enough bubbles that they aren't so visible. Might just go with a lower threshold. Learning from other people. I've learned from other people. I think it was Julian today pointed out the he's passing along a tip about doing like reflective surfaces. But yeah, I think even doing streams, like it's cool because it's kind of a both way learning process or whatever. Yeah, it's cool to share your workflow or even get feedback of like you miss like you're doing a stupid decision that is super obvious to everyone else and it's just wasting time or it's just a mistake or something like that you never realized. Yeah, that to me is what's nice about streaming right now is that it's kind of replaces like the being at a studio and just having someone like by your desk bouncing ideas off them or picking up tricks, seeing what other people are battling with or succeeding with. So that's to me is why it's the closest replacement to basically doing like the desk side chats. We got a lot of bubbles. This is super carbonated. Might have to increase refraction trace depths. So yeah, to see more bubbles, you might need more. This is the NASA Tang orange juice as they're taking off or something. Yeah, we can try going with more refractions. So I don't know what you'll go with. I don't know. Usually I either will just turn it up quite a bit if you really need to. Because I have this scattering, like the internal dimming or darkening of the rays. It will kind of take care of that, but if you had like a crystal clear fluid, you might have a lot of overlapping bubbles or something like that that you would expect to, like the light would keep passing through them more easily. Maybe just 6. It's a good balance. So yeah, if you really wanted to be physically accurate, you could switch around to only showing the bubbles based off of high velocity areas. It's kind of like doing a whitewater simulation. You can produce bubbles using the whitewater tools in Houdini, but usually just keeping a subset of the flip simulation gives you a good quick result without having to do any extra like secondary simulations or anything like that. Let me go up here. Show the velocity away. Yeah, I don't know how well it will work. Renders so fast. Yeah, that's the one thing with Redshift is like, if you're trying to do any reflective or refractive surface, the CPU ray tracer, I'm only comparing it mainly against Mantra. It was like night and day. Like everything. Let me see if I can do it. So just start the render. Stop it immediately. It would take Mantra like a minute to get to this point of noise, and like moving lights around or even getting something like changing values on shaders could take you like 10 minutes. It's like super frustrating. So if we look at our flip fluid, this is already after the trail is computing velocity. So this one right here is just a visualization. The length of velocity becomes the color or the brightness, the luminance. If you wanted to, let me just put this here. I didn't try Octane. Basically, when I decided to do the GPU rendering route, I think Redshift was doing a sale at the time that was like 40% off, and then just looking at the forums and stuff like that, people were saying that the Redshift plugin, the implementation with Houdini was more straightforward, so that's why I decided to go that route. But yeah, I don't know overall in terms of speed and stuff like that. Some other people have done more comparisons. I think overall they're pretty similar, but there's certain areas like maybe volumetric scattering or displacements or stuff like that where one might excel over the others. I think there's also I don't know if it's just with Cinema, but with Octane there's like this Vectron stuff. For Fractals, I think it's with the combination of Octane and Cinema, maybe. It's possible you could do it with Houdini. But I think this is just like a specific render procedural that the Octane people have written. I always wanted to try it out, but I was never able to. It's like with Arnold, they have like a Mandelbulb procedural as well, but basically, I don't know how open this is, that you could code your own fractals. It's pretty cool that It's like, I think once you have the OSL, open shading language with Redshift, you could kind of do your shader toy stuff or whatever with at render time that way. But right now, Redshift is a little code less, create more. I think the Spectrum uses OSL. All right, we're gonna get back to the kind of speed-based bubbles. So I've just made this attribute here that's speed. I'm just gonna make it a little easier to visualize it. So our final thing will just be an integer called maybe condition. And that's gonna be just a true or false, like 0 or 1, that will determine whether or not we delete the particle or keep it as an air bubble. So if I reconfigure it, we still have the same result. We can still do different seeds, but I'm just doing it this way so I could visualize it. And I'm just going to comment this out. It basically made everything black that was getting kept. The white stuff was getting deleted. So right now we have a ton of white areas. It's basically saying true, or if the condition is 1, remove the point. So instead of this, you could say like, is the speed greater than 2.5 meters per second? We've isolated that range. 4.5 meters per second, isolated that range. This is just looking at how fast the fluid is moving. So there's a few different ways to go about this. Trying to think what the best way to do it is. So like, maybe if the speed is greater than 2.5, but then you also factor in this condition stuff that we were doing. So like the speed multiplied by the random number, then you're keeping a subset of the faster moving area. Then with this random number, if you multiply it or do some interesting stuff with it, then you can further like gamma or balance the randomness. September, how's it going? So like, if we do random number, but you do like a exponent power raised to the 4th, then you're going to be keeping a lot less of things. So that's one way to do that. I think as well, if you just multiply your random number by something like 4, then you're widening the range of like how, basically if you just multiply this by 0, or I think just 1, you have like a pretty harsh fall off between areas that bubbles can grow or not at 2.5. So if you double it, then you have a little bit more of like a feathered range. Having difficulties with my flip inside closed geometry. Brain is melting. I'm not sure. The only thing I can say off the top of my head is like, just to make sure either your collision geometry is like a shell, like it has thickness to it, or if not, if you're doing collisions, make sure you're doing invert sign. Like if you have a sphere like this, you need to invert the sign to make the solver treat the inside of it as empty and the outside of it as solid. If it's polygonal and you did a poly extrude or something to give it like a shell or thickness, then you wouldn't need to worry about that. It's like, just do a clip. So this way the solver is smart enough to know about it. Other issues can be like substeps. If you have a lot of turbulence or fast moving particles, sometimes the solver won't know like to bounce it off of a very thin surface. If you have a particle that's here one frame and it has a magnitude like high velocity going this way, it will skip through the surface if you don't have enough substeps. But yeah, flip generally you will melt your brain among other things. Volume loss. Yeah, the volume loss is never really going to be physically accurate, I think. Like, you're always going to be fighting against things, whether it's reseeding, you could gain, overcompensate, and stuff can expand or gain volume over time. So yeah, that's definitely, I was having some volume loss on this sim as well. Yeah, it's inconsistent. Even like moving to a lower particle separation, I had to increase substeps just to have like the similar motion. Otherwise, I was getting like jagged edges and stuff like that on my end. So basically, the more that I multiply this random number, the less I'm relying just purely on speed to eliminate particles. So you would have like a wider bandwidth or a wider fall off between still slow moving areas not having any particles or the other way around. So you could reset this to condition, and then when it was looking as the color before, like I would just want to flip this around because the black particles are the ones that will be left behind. So basically the way that this is set up. So I think if I just set it this way, I think you go with a lower number. I might want to switch this to a gamma, like a power. I think that's going to be easier to control. The power function is nice because it will keep it within a 0 to 1 range, which blew my mind. I think I blew my own mind. I think this power method will be easier to control. All right. I don't know. I don't have a good way of really controlling this easily, but I'm just gonna try trying a combination of the two of them. This could be a good starting point. I don't know, it could be too many 6,000. Okay, that sounds like a little bit more manageable. There's some fixes you can do to do these little penetrations, like where the air bubbles are sticking through. I'm just gonna go with it right now because it's just trying to move quickly. So yeah, that's the idea behind this. So it just looks a little bit more natural, I guess. Like you wouldn't expect to see a ton of bubbles unless this just settled down or it's like foaming around or whatever. And then as the areas with like higher turbidity or higher speed are moving around, that's where you would expect to see air bubbles. Like you turn on a faucet, sometimes that water is like fully opaque or like white water or blurry or whatever because there's like bubbles and they're motion blurring and they're reflecting or catching the light. Yes, that's air bubbles. So let's do one more subsurface. Maybe just take a look at how close we can get to like a milk. So right now this, these materials I've been using, this subsurface down here is a little bit of a fake. Like it's kind of for tinted glass or absorption or that kind of stuff. If you just go to like a plastic starting point and then you work with this subsurface multiple scattering, this can be a little bit more physically accurate, I've found with Redshift. Like you could see with the settings down here earlier, I was kind of, stuff was too saturated. It would be like burning out or amplifying the light too much. So if we just go 1.33, get closer to reflection for water or something. Maybe a little bit of blurriness on the surface. And then diffuse, I'm just gonna make that all the way up to 1 like white. And then if we just go to the subsurface tab, turn that amount up. So this is doing a little bit more proper ray traced, like physically accurate. This subsurface of the under the refraction tab is a bit more of like a hack, for my understanding at least. It's like looking at something called the Beer's law, like light attenuation. So that method is just looking at the distance, how far the ray is passing through the light from when it enters and exits the fluid to figure out how much it's going to absorb light or attenuate itself. This subsurface I find does a little bit better of a job of like blurring stuff, and it's just more realistic overall. Like this kind of blurring of the internal like bouncing and reflecting of the light, like putting your hand over a flashlight or something, you can never really get it that well with this refraction based like subsurface transmittance. So for milk, things like that, this method can be a little bit better. The radius, I'm just gonna try something a little bit lower. You think it's like a bit of blue that milk does? It's still maybe like a bit of orangish yellowish. I think it's got like a little creamy, warmer scattering color. There's really good commercials. I think maybe it was Method. They did some really good CGI milk. I don't know if it was the anthem. So yeah, it was just flip surface tension. But the subsurface, I guess here you can see it's getting a little bit warmer. So yeah, that one right there is definitely looking like it's getting some orange creaminess. And I think my lighting, I might need a little bit more intensity, exposure to get it closer to white. I don't know if it's just like less reflective overall. It's more of like transmittance. Getting more away from water maybe. I think this blur is a little too much. Maybe getting closer to like the yellowish, orangish. Stuff is starting to look pretty good. I think I went just a little too much saturation. Try bucket. Yeah, that's a good idea. I think the subsurface is just so noisy that it's hard to evaluate. I think as well on the renderer, just make sure it has some more sample capability. Yeah, I don't know if it's these thin areas might have some issues. The GI, yeah, that might be it as well. It's a good call. I don't know what the best solution is. Sometimes I'll end up like baking in an additional subdivision layer. Seems like sometimes that will help Redshift with the shadows a little bit. I don't know if it's gonna wreck me, but sometimes turning on the tessellation can help with the shadowing as well. Maybe the maximum, we're already like pretty subdivided, so I don't want to add too crazy iterations of subdivision. Let's see how it compares. Gonna grab some more water. Does it look like it helped? Looks like it's improved the edges a little bit, but other than that, not really. It might be, let me turn that back off. Sometimes with these meshed, you just get rid of the bubbles. We're not gonna see that. That could have been it, was that there were like a shitload of bubbles all intersecting, because that was like the high velocity area. What I found, thank you. Yeah, we switched over to a milk kind of vibe for right now. Sometimes with these meshed surfaces, if you do normals, but instead of the default cusp angle and everything, for VDB mesh surfaces, sometimes I'll go by face area, and that will seem to be a little bit better. Just do another bucket render. Yes, I am really standing. It's always hard for me to find a sitting situation that's ergonomic for long periods of time without like a ton of monitor stands or elevators or whatever. Just because I think I'm not like a typical height. It's like 6'4", 6'5" feet, so it doesn't. So it's harder to accommodate that dimensions, I think. Like usually if I'm sitting, my shoulders or whatever, nothing's at the right level. So yeah, it doesn't look like any of that stuff has really made a tremendous difference. So I think this is getting rid of those were little internal bubbles that was causing that kind of stuff. Yeah, I don't know. It might be a situation where going back to like the milky coffee starting point could be better. Let's give it one last try. Let's see what happens. It's just a little weird that the thin areas like are so blue in my previous render. So kind of weird that they're so dark. Let's take a look. Let's get this less orangish. Could try something like that. And then again, just restore the IOR. The multi-scatter really only seems to work for skin type materials. Yeah, it could be. It's just it's not like the random walk, or it's not a super good ray trace mode for like really thin surfaces. But I don't know, like for an earlobe, you'd still expect it to perform pretty well, at least. So we'll just add the diffuse component back in. I think get rid of the reflection. Maybe just add the roughness in. Maybe I need to just make the, this is going to be a funky material. Yeah, I don't know. It's just too much there. This way it seems to at least solve that thin area issue. So this is kind of hacky, but it seems like just balancing some of the refraction strength to give it that color seems to be pretty interesting. So just overall maybe a bit too saturated. So a bit more consistent, like the subsurface kind of color. Just play around with these lights a little bit more. Yeah, it seems pretty tough with this to really nail a good looking milk. This thing. Looks like it might be getting somewhat close. doesn't look completely repulsive. So yeah, I was just gonna try a quick Blade Blast, or I guess, I don't know, render flipbook. See where I get with it. Julian, thank you. Yeah, it's, I don't know, it's some weird funkiness for sure, but this is definitely starting to feel a little bit better. Yeah, I think you're right with the multi-scatter really only nailing it for skin-based materials. Maybe it's possible you want like to pull some attributes from the surface, like the curvature or something, to drive the scatter radius or something like that, but it doesn't seem like you should have to do that for milk. I know for skin shaders, you usually do like the scatter thickness for ear lobes areas is like a broader scatter radius. It's possible I want to do something similar for like based off of curvature, but the milky coffee preset seems to be holding up somewhat well. So yeah, I'll probably be wrapping up pretty soon for today. There was some ideas I had with this stuff. So like, instead of this hourglass like transfer from top to bottom effect, I was thinking it might be more stable or more interesting to start with fluid both on the top and bottom, and to be transferring constantly, like things are exchanging from one side to the other. Maybe doing two different colors, like coffee and cream or something like that, so that when they plunge in, you would see like the color like diffuse out or something like that. It's working better with the black background. Yeah, the HDRI in the, I don't know, on white was a little funky. I think milk looks good on black, but actual water looks better on white. I don't know. It's hard to get actual water looking good. Like with, I don't know, the backdrop is a lot of it. It seems like with refractive stuff. But yeah, I was thinking having a bi-directional thing where this droplets are going from the top to the bottom and the bottom at the top. Might be a more interesting way to do things. Oh no, you're right, it is visible. It's a little, the key grip is responsible for that one. It left the light in the frame. Another 2-part tutorial. For YouTube, a proper one. It could be fun. Yeah, I have some other ideas for tutorials and stuff like that. Kicking around. Also getting it set up for a actual proper online school teaching. I don't know if I'm ready to announce it yet, but there is content I'm working on in that respect. Doing this like metallic smoke simulation and then rendering it this way with like weird complex surface or whatever. Yeah, I'll be sure to let you know. I'm still looking into things and getting a date and time and stuff set up for it. But yeah, it would be like a 90-minute, pretty concise, but is still interactive online training thing. Similar to the skull. Which skull? Kudo cores. What is Kudo? Is it you're counting in a different language? Quad? Kuda. I don't know how many overall, but this is just with the RTX 8000. I don't know a good way to spit out the... I don't think this one says. Maybe it says it in the Neo fetch. I don't think it says. It's the RTX 8000. If you look up online, you might be able to find it. Yeah, the one I did to Instagram. Yeah, with the copy. Yeah, it has a similar ideas with coloring, changing materials and stuff based off of the surface curvature and things like that. But yeah, I am looking to get back, hit some more YouTube tutorials. As it feels like it's been a month or too long with those ones. All right, we'll be back Friday. Cool zone. Hopefully we'll still be back. So see everyone Friday. Yeah, and I'll keep messing around with this or whatever. Hopefully everyone enjoys the rest of their week as well.